John and Nancy Hutchison, hello.
Hello there, how you doing?
And we're going to be going over this particular video and telling you things that are happening there. And we'll see how it runs here. Let's go.
Okie doke.
What is this, John?
Oh, it is a small Tesla coil, about 200,000, 300,000 volts, running and igniting a fluorescent lamp.
And what's that ball on top? What's that made out of?
And that would be a copper ball.
About what's the diameter of it?
Oh, I would say about 6 inches.
Okay, now we're going into another piece here. This is part of the main big lab.
That's right, yeah.
You have a fluorescent bulb. And what are you doing with that bulb?
Well, what I'm doing with it is lighting it up with an electrostatic generator, which is very big. It's about 9 to 10 feet tall. 2-foot diameter ball on the top. I built it, my own design.
Is that a Van de Graaff, or that's just something you built?
No, it's a Van de Graaff. It's something that I did build, but to my specs.
And you're using the bulb to do fine-tuning on it?
Kind of like that, yes.
And there's something over your head there. What is that?
Oh, that is a huge toroid. Aluminum toroid that collects electrostatic energy and discharges it in other locations.
And then there's this other piece here. It's the top of a transformer, I think.
Now, that would be part of a Tesla Coil specialty item I built.
And you got zapped. How do you think the zapping happened? What happened? It jumped
through the glass into my arm and to the ground.
This down here is a what? What is that?
That is a static accumulator as well.
So you're trying to build up static electricity inside of these?
That's correct, yes.
Ah.
So what I'm doing is tuning it up to optimum voltage.
Okay.
As you can see, it's got special corona suppressors on it and enhancers as well. Back of the interferometer, also in view, is part of a giant transformer happening.
Right, but the white
capacitance.
The white is the capacitance used for the interferometer?
That's correct, yeah. It's a kind of Tesla design type thing. My own special field shaping.
Are you touching the bulb up on top there too? Is you're trying to ground the bulb?
I'm actually trying to ground it there so I don't get too zapped out. I'm kind of dwarfed by it, as you can see.
But how tall is that? About 10, 12 feet? No?
Yeah, but it's well, the ceilings are 12 feet high. And that has to be around 10. 10, maybe over 10 feet.
And what's happening here? You're fine-tuning, but what are you looking for?
Well, intensity and repetition of intensity of static electricity.
And so based upon what you're observing with the light bulb, do you then make some adjustments to the equipment?
Absolutely, yeah. That's what I do.
So you're looking for more zaps, less zaps, more intense? What are you looking for?
Well, I'm tuning it towards optimum output.
How do you know that it has an optimum output?
Brightness of the fluorescent tube.
So when the fluorescent tube is really bright, you know that you've got a really good output. That's
correct. Actually, we use that in RF testing of antennas as well. The fluorescent tube.
This back here, what's this?
That is a giant horizontal Tesla coil.
So that's the primary on a Tesla coil.
Yeah, pancake type.
All right, so now we're going down the big Van de Graaff, and the left of it is part of that transformer, is that right?
On the left there, yes.
This is a transformer you designed.
Exactly.
So let's explain this part of the Van de Graaff. This is underneath the big ball.
And all adds into an RF output and energy and accumulates static.
On the top is a thicker ring. What does that thicker ring do?
That's for lower frequencies.
And then you have a series of bands that run down the pipe. And what do those bands do?
Those bands enhances frequencies.
You have a toroid coil around. That's, and the purpose of the toroid coil is to
shape the energy output.
And what are you trying to shape it into?
What I see in my head. A workable energy field.
A workable energy field, something that has form to it.
Yes.
And it's like a three-dimensional kind of a
yes, three-dimensional kind of electromagnetic waves.
This right here.
Well, that's a gigantic insulator of 100,000 volt 3 kVA transformer.
Why is it crooked? Why isn't it straight up in the air?
Because they do that so substations can send out the lines properly, and the bottom part away from the casing.
Okay.
So it doesn't spark.
And the ball on top of that, was that something you added or was that with it?
Oh no, that's something I added. It's a Corona suppressor ball. You don't get sparks out blasting into the air.
Basically, you're trying to control all of this voltage in it so it doesn't go zapping all over the place, and it does what you want it to do.
Yes. That's the bottom part of the Van de Graaff generator.
That's the bottom part. And there's a outside ring, and then it looks like an upside-down pot.
Yeah, that's where the separation of charges happen. It's got boosters and insulators and all kinds of cool stuff.
So you separate the charges and you pick out which one you want to use?
Well, no, you just separate them into negative or positive electrostatic units.
Kind of like a big recipe, isn't it?
Yeah, that's well put.
Okay, and this, what is this here?
That is a high-powered X-ray transformer. 400,000 volts.
So there's 400,000 volts. Is that feeding the Van de Graaff?
No, that's a separate system.
It's a separate system. Now we're at the transformer.
The big transformer. 2 tons of it.
And this piece of the transformer is?
That's the other insulator, the other part.
And it also has a Corona suppressor on top that you added?
That's correct, yes.
This is part of the original right here, or is this?
No, that would be the original.
That's the original. And then you added the top ball as a Corona suppressor. So now we're going in on some other pieces that are in the back there, and there'll be more on that. But what are these guys here?
Oh, well, one is the original spiral spark gap. Original spiral spark gap I built, along with RF chokes and connecting high voltage balls and coils.
Now this is the big guy, isn't it? This is the transformer?
Oh, that's Tesla coil, my own design. That I actually copied part of it from plans, and it's 2 feet diameter, 10 feet high or more. Puts out 10 million volts.
10 million volts. And was this that you started with the plans from Tesla's plans? Or what plans did you start with and then you adapted?
Would be Tesla's plans.
And why does it have that little tiny ball on top?
To guide the high voltage out.
Guide it out into a very small ball.
Low Q, low capacitance, but has its purpose.
Okay, we're back onto the transformer.
Yeah, big fella, 2 tons, 3 kVA, meaning kilovolt amperes. Same duty as the Westinghouse transformer, Colorado Springs Lead 1900.
That's what Tesla had.
Not like this, but he had the same ratings.
And we go back in and look at the chokes again.
Mm-hmm.
Looks like this might be a little bit of a repeat from... So we're kind of going through the same thing again, and we're back to the big Tesla coil that you made.
And he zooms in. In this building, downtown Vancouver, the old Murchie's Tea building, 5-story high.
Were you in the first floor?
Yeah, basement.
Or in the basement, okay.
Oh, yeah.
All right, now we're swinging around to a bunch of gauges.
Very interesting gauges, all very vintage, along with naval gauges, and also adapted to reading frequencies, heat, amperes, phase shifters, other frequencies. I like building the best.
So were those all military?
Navy. All Navy stuff.
Now we've got this, looks like a globe with two circles put together. What is that?
That's what they call it. They use them on Navy ships. And they're what they call direction finding antennas. This is 200 amp variac.
And so this was used to vary the amount of power that was being sent in?
Yes. I use it along with the 89 or the 100,000 volt transformer. These are more power meters. Turn of the century type.
And were those hooked up to the variac or to something else?
They'd be hooked up to variacs, supplying voltage to all the transformers.
So this is how you're able to gauge the amount of power that was being fed.
Yes.
We've got amperes and all kinds of... Looks almost like a chart on the bottom here on the left one.
No, that's a different type of movement of a meter, power meter. Came out of a substation.
So we've got an overview here of the gauges, lots of gauges. I'm going to swing around here and look at this piece that has a couple of orange dials on it. What is this, John?
Okay, those are the matching direction finding radio receivers to those two antennas, loop antennas. This is a stack of variacs where I can control the voltage to transformers. Pilot light. And it gives the direction of the radio waves.
So you were able with the radar to pick up where the waves were actually happening.
Not really radar, but VLF, very low frequency. So
We've got more gauges.
More gauges. Some are temperature gauges measuring the temperature of the transformer oil.
I guess that wouldn't be good if it got too hot.
No, or too low of oil. It will explode.
Well, now we're panning around here to a bunch of metal boxes with dials on them. Explain what those are, John.
Well, most of those are RF generators, test equipment, radio receivers.
Vacuum tube.
Vacuum tubes, an old sonograph on the table there, along with that big box there is a gyro test set.
Military.
Everything has to be military. Radio analysis machines. Will measure in...
Is that what this is right here?
Yep. Vintage, very old vintage tuning coil system. Right there. Tracking radar systems, an antique vintage receiving horn.
It's a receiving horn. Is it functioning, doing anything there, or just look good?
No, I had everything working well. Very well. Radar, little radar. A Raquel, radio receivers, test gear, RF generators, field strength meters, a radio coming in on an antique radio.
So you'd have some headsets and you'd put them on your ears and you'd listen to the static.
Yeah. Tells me a lot of stuff. It adds to my visualization process. That's a reader, telegraph reader. That's military radio set. And it's a battery of the same military radio set.
Battery in the sense of
many of them.
Many of them, okay.
Yeah. Extremely well made. U.S. military. And some more test apparatus down there.
Testing the frequency, the strength of the frequencies?
Yeah, that's a whole radio receiver, that one big rack.
Light-colored rack.
Mm-hmm. Okay. A little radar.
Radar.
A accelerometer.
Sarah receiver.
Yeah, used in aircraft for detection of radio waves, guidance systems. Vintage tuning system. Black box and back up to the accelerometer. Used in communications and distance locating things.
So you're able to kind of figure out the distance that these waves were to try to figure out a target area?
Yeah. Got a little dish antenna on the side of it. This one does. Made in South Africa.
Okay, now we have another view from a different side of the room that has all this test equipment.
Yeah. Lots of test gear. I see we're zooming in on a radar set. And an echo box. More radar, oscilloscope, special kind, Navy. RF generator, receivers. I think that is a radio test gear. Back to the gauges. Control panel. That was one of the main control panels. With an AR-88 in dead center for listening with. These are out of a substation, these meters. I remounted them properly.
How long did it take for you to put this together, John?
Actually, not too long. I do multitasking.
How long is not too long?
A month or two.
A month or two?
Mm-hmm. That's a little better view of the big Tesla coil of 10 million volts.
And then we have some other things, like another big ball we just went by. And we have, all of these things. So let's kind of look here at what this is. We've got all these circle forms. What are those?
Circle forms are for guiding and moving RF and high voltage, as well as electrostatics around in different positions.
Made out of copper?
Copper, brass, and aluminum.
And then this over here, it looks like just a whole bunch of light bulbs set up there. What are those?
Those are big triode transmitting vacuum tubes that be in operation, glowing in the dark. That looks pretty cool. And pulsating plate transformers and all of that to operate heavy-duty stuff.
We might go back to that, I think, in this, and we'll go over a little bit more with it.
And also you see a string of insulators.
In the middle?
Yeah, glass ones.
Those are the triodes there?
Big triodes. Here is a...
insulators.
Yeah, a string of insulators.
And what was it insulating against? What was going on?
Oh, you want to insulate very well when you're running 400,000 volts through something. It's a special German loop antenna.
Right, and then we have what's on the bottom shelf. What's that on the bottom shelf?
Those, I had many of them, more than that. You've seen that, I think about 20 of them I had. There are giant capacitors, low inductance type, 25,000 volt DC voltage, plasma capacitors.
So you'd load them up with energy.
Load them up with direct current, high voltage, and discharge them.
And what would they be discharged through? What were you...
Big spark gap. It sounded like a cannon going off. 2 posts from 400,000 volts X-ray transformer there, the green thing, dropping down to another transformer and a giant capacitor that was probably about a ton.
What is that upside down?
That's sitting on the gigantic capacitor.
Those are the posts from the transformers.
Yeah. Big inductors hanging from the ceiling. G3 capacitors stacked together. The German loop antenna.
It's something on the wall. What's that?
Okay, that is a vintage, probably 1880s voltage regulator using carbon disc.
Here's the big main off switch.
That is the big main off switch, on and off.
Breaker.
Vintage. Well, I built it.
And then we have some more of these guys here. Oh, yeah.
Transformer regulation gauge.
Now we're looking at a different angle.
Different angle.
The static collector was up on the top right. We come down here, and this is
a turn-of-the-century giant reed engine lathe that I got for a couple $100 and restored the entire thing. Flat belt type. And it was a lot of fun to use.
You use this to make a lot of the equipment in the lab.
Yep. And a small Busy Bee tool milling machine. So I've been buying stuff for a long time for that.
And what's this here, John?
And then we're getting into voltage regulation. Turn of the century.
That looks like a huge variable capacitor. With little fins?
Yeah, that's actually quite the unit. It is voltage regulation.
And what do we have down here?
Oh, those are... Okay, that's a variable inductor.
Lower right side is a variable inductor.
Yeah, and that is a high voltage capacitor.
On the left side?
Mm-hmm.
Now this is kind of, what's this? This is kind of a different kind of a coil thing going up here. What's that?
Yeah, that'd be induction coils.
Both of these? Nope.
That is. The other is an RF coil.
Oh my, what do we have here?
Well, you could say that is a gigantic RF projection system.
One of the big ray guns.
Huge, yeah. It was pretty massive.
And if you look, it has a toroid on it.
Yep.
And what's behind here on the right side?
And they were all big coils. So you pump connect the RF high voltage electrostatic into that and tune it all up, and it'll do all kinds of crazy things, which I've seen.
Goes to a point with a little ball at the end.
Yep. And it was pretty reliable.
That's the other side of it, other view of it there.
Yep.
And we go out of focus, and let's see the end of this thing. So you're creating a huge amount of RF, and then it all comes out at the very tip there.
At the very tip of this film.
So there's several toroids.
Toroids. Yeah. And capacitance at the back of it.
Well, that must be the back side of what we saw earlier in the film, that white.
Could be. I made another one, lighter one, like that.
Why the white disc? What were the discs doing on the back side?
Electrostatic capacitors. Kind of like Teflon. They were Teflon.
So what do we have these things that look like upside down pans, bowls all over things? What's the upside down bowl for?
Oh, corona suppression and transmission. That is a gigantic, yeah, that's what that is. That's an RF choke. Coil. Capacitors.
Going back in on that group again. In the back, you said those are choke?
Roller inductors, choke. Tesla coil prototypes. All vintage high voltage type design and engineering. Yeah, kind of cool.
Oh, we're coming around the side of a big ball, and oh my goodness, it looks like a cannon. Cannon through a what is that, John? And why is it that way?
Well, it's kind of like an antenna with a field shaping waveguide right around it, so I can tune that waveguide, different angles. And
then here we have on the right side is the horizontal Tesla coil.
Yeah, I was around until 5 million volts. It's still not hooked up. I have a direct wire off of that terminal. It's going somewhere.
So this was videotaped before you had everything hooked up?
Yeah, it was getting hooked up. There's a black and white video with it all hooked up. The only other video is Canadian Broadcasting Corp.
Which we need to find that video.
Mm-hmm.
What are we going in on here? What are these things? Little balls. You see little balls lined up.
Yeah. That actually is a gigantic variable spark gap that is operated with a huge transformer.
Was that from Tesla's plans or yours?
Actually, my plans. They're magnetic balls as well.
Now we're getting another close shot here on a interferometer. And pulling back on the ball. I believe that was from the transformer, maybe? Oh, what are these black boxes here?
They're vintage 1920s, what they call variometers for tuning RF. RF choke.
This is an RF choke here.
That now, I believe, is in Germany.
Now we're looking at the toroid coil. Another toroid coil, just hanging in the air.
Hanging in the air, and the insulator. High voltage will be attached to it.
So you spin the high voltage around the toroid, and it goes out someplace.
Oh, yeah. Okay, getting into spark gaps there. Sitting on a table.
This looks like another transformer on the right side.
No, it's the same big fella.
These are those glass balls again that you said were the... Here they are.
Sitting around a gigantic tunable spark gap.
And what would the balls do?
Well, they'd let you control the output of high voltage by tuning it, separating it.
Getting it close on.
Mm-hmm.
There's that transformer.
Freebie. All 2 tons of it.
Wow.
Delivered.
Wow.
It's 400,000 volts vintage transformer with 2 probes coming out, round balls. Featured on several news stories. Tesla coil thing I built.
This is a Tesla coil thing you built special right here.
Mm-hmm.
Looks like a static accumulator again.
Yeah. You stand there is 400,000 volts.
To the other side of that.
Antique transformers.
And then that looks like a lamp there, John.
Oh, which one? That? No,
Yeah.
That's a Corona suppressor on a 1-ton capacitor.
More gauges back here.
You got more gauges.
How did you keep track of all the gauges going at? You had to be looking at the gauges and listening to the static and moving the dials. I mean, my goodness, how many things did you have to do at once?
That's why I don't like people around me when I'm doing things. When I'm doing anything.
This has got a glass. Is this glass in here?
I had glass insulators and glass capacitors.
What's this guy over here?
Field shaping system. Sitting on top of a high voltage transformer, 30,000 volts. That is a variable, gigantic capacitor inside a tank with a pressure gauge.
Now we're going up to another ray gun. What is this, John?
That's what they call a dumbbell Tesla coil.
A dumbbell Tesla coil.
Yeah, it's got terminals at both ends of it, and it'll shoot sparks out both ends.
Corona suppressors on it as well?
No, just Q adjusters.
Oh my goodness, and now you have this guy that has all these little balls along it. So what's this?
High voltage sprayer.
Sprayer.
Yep.
And we have a disc here that's a circle of aluminum. What's that? Or bright shiny stuff?
That would be a Hertzian loop, and in front of it is a gigantic suspended spark gap for discharging those giant capacitors you saw previous.
What was the purpose of the big loop?
Just to measure the discharge.
Okay.
And to make it shock it kind of thing.
We're back to those triodes, is that right?
Yeah. In the DC transformers, X-ray transformers were inside their gigantic diode packages.
We are back on some more triodes or something. What's this, John?
That's a part of the Van de Graaff generator. At the bottom of it, spark gap. Other spark gap.
And up here, that's a Van de Graaff?
Yeah, that'd be 500,000 volts.
This one you built, or?
I actually repaired it. Mel Ernest Winfield gave me it a long time ago. I had to rebuild it because it was kind of wrecked. Little motor, drive the belt. Oh wow, that's big variable capacitor.
There's something.
Yeah.
Oh, what's this, John?
Look, that's followed me in various labs. That's a field shaper. That's what Hathaway talks about.
Why is there like a spring or this over here?
Just high voltage lines, spring shape. And that's a battery of G3 capacitors, spark gaps, capacitors.
There's a big spark gap right there.
Yeah. Roller inductors.
Now you've got balls on your spark gaps. A lot of times people have points.
A lot of people have points. I'll have points too.
Why did this one have balls?
Stabilization.
These along here.
Gigantic 35-pound copper, silver-plated roller inductor.
Roller inductor. We had the little ones in our hands, and look at how big these guys are.
They're huge.
There's a close-up of...
Gigantic spark gap.
How many spark gaps did you have going in there?
Oh, many of them. Don't know the exact number, but well over 10.
These little magnetic balls underneath it for tuning?
No, that's just ornamentation. I build everything to the best of standard. We're getting into exotic stuff here. High-powered tube, and this is a nuclear reactor.
What do you mean it's a nuclear reactor?
That's where I have my uranium source in that thing.
What would the uranium be doing?
I needed extra help.
Extra help?
Yes. Alpha and beta and gamma radiation. Inside the round ball at the very bottom of that thing.
This looks like a cannon right here. What's that?
No, actually it's a machine tool that adapted to variation to ground. High potential. You can adjust it and had a point on it and would vary the ground to the nuke.
And then we have something here with a glass insulator or glass tube and a ball on top.
Yeah, special electrostatic kind of ray gun system.
What's this right here?
Vacuum tube. Big air-cooled tube.
Capacitor?
Yeah, big fella. Another view of the same area, I think. Yeah.
Well, what's this on the right? This is our nuke, but what's the one on the right side?
Well, that was one of the first ones I built, coils, Tesla coils. It's got all kinds of different field shapers on it. Let's see, we're getting into back to the nuke. Stainless steel ball where the radioactive material is kept.
So now we have over here your very large Tesla coil on the right side, and I've got something with a ball that has some... What is that?
It's a high voltage output, I think, from a transformer. So it's on an angle.
There are two tubes that are flanking that. Why?
Yeah, field shaping and guidance of all this stuff. And all that cool stuff.
So we're back to...
Gigantic roller inductor?
Yeah, that's huge. And what's behind it? That's the gigantic roller inductor.
Capacitor? Kind of like the one used in Colorado Springs by Tesla a long time ago.
What's that behind it there?
Oh, those are transformers used for measurement of high voltage. So you put high voltage on the top, then read out a very small amount at the bottom. Oh, yeah.
Don't know what that is back behind there, but all right. So now we're going along.
Engine lathe and flyball governor used in steam engines. A restoration job and a revolving cannon I made. That's the end of it, the barrel. Made out of 4140 steel. Down. They're quite heavy. To the actual frame, the cylinder in the middle there, you can see that. Highly ornate. Another view of the engine lathe, Reed style, 2,000 pound lathe. Glass boilers there. Classic vintage piece that I had a lot of fun restoring. Back at the old Reed engine lathe, turn of the century type, flat belt driven. Nice design. I'm moving along to more machine tools, a small milling machine, a rotary table. Bought from Busy Bee Machine Tools a long time ago. Those two round handles on the wall are off of a 90mm anti-aircraft cannon I purchased from Amick Salvage for $200 only. I did take about a third or more of it apart, moved it to another location. Vault door I restored and built.
Who is J. Hyatt?
J.H. Vault door.
Oh, John
Burnaby.
Hutchison Vault door.
Burnaby.
Were you in Burnaby then?
Yeah, this door followed me around all over the place. I modified it to have two sets of dials on it.
You're really good at cracking those vault doors too.
Yeah, I like making them too. That was a cool restoration job. I made a vault inside this building in the basement.
And there you are.
That's either me or somebody else opening it.
That's you.
So we have on the ground there a tiny cannon that was 100 maybe 200 pounds. One I built from scratch.
There you are again.
Yeah, that's another take. So in here,
I see a lot of long rifles.
yeah, they're mostly World War II vintage, World War I, few Civil War guns, machine guns.
We'll go in on some of it. Oh, there's that little cannon you made.
Yeah. 2 feet long.
And the pistols on the shelves.
Yeah, all these antique pistols.
Now, there was a time when you got raided and all your firearms were taken from you. Was this some of the collection that was taken from you?
Yeah.
But you got those back. Oh, and now we're back to...
Oh, yeah.
I notice it has this little spin of light around it when the camera moves. That's the tip of what interferometer?
The big fella.
That's the big fellow.
Yeah, the film person filming this noticed that kind of strange effects with it.
Was there anything running at this time? I know there was a strange noise.
No. But sometimes people that have stayed in the lab notice that the machines do strange things unplugged. We had that happen with the government test.
We've got a coil coming off of here. What's this coil?
That would be a high voltage lead.
How did you figure out how to make these things, John?
Instinct. Faster than math and measurements sometimes.
Now, this is our big spark gap again.
Yeah.
Looks like some kind of a vise that was modified.
Oh, it was a tuning system. Machine tool parts. It was pretty heavy, that thing. And that's a handle for moving it back and forth.
And we've got a static accumulator back there. Is that what that is?
Yeah. It's zooming in on it. A big static accumulator toroid, and I think it goes under it and filmed it.
What's underneath down there? Got some ball in there, too.
Yeah, small ball. Corona suppressors.
Insulators. Don't want to get shocked, do you?
No.
Do that with the fluorescent light bulb enough. So now you're in the back here.
Mm-hmm. 400,000 volt transformer.
Yep.
Vintage.
What year do you think that was?
Oh, 1920s. A lot of vintage stuff. Even stuff that Tesla used, made by another company.
These are the roller inductors.
Roller inductors again. Spark gaps.
Spark gaps with insulators.
Yeah. Properly done. Mounted on bakelite. Black bakelite.
Non-conductive.
Very much. Do it to the 18th century standard.
1800s.
1800s, yes. 1800 standards. A nice, juicy capacitor. Gigantic 35-pound, 40-pound roller inductors.
I noticed how a lot of these pieces of equipment have little, they're connected with pipes or coils or...
Yeah.
So they all kind of work together.
Yeah, that's the way they used to do it, with pipes and straight lines and high voltage connections.
This looks like a transmitter tube inside of there.
That is a transmitter tube.
Like they use those in the RF radios.
Yeah, FM stations. And we're back at the atomic reactor. Nuke source.
For a different energy field, was that?
Yeah.
For the purpose of it.
With support from Dr. Wilson at DREP, who was quite intrigued by that. He felt the fields picked up the radioactive material and put it somewhere else.
So the fields that you're generating actually basically sucked up the radiation.
Yeah, that would be on actually recorded, hidden in the Canadian government archives somewhere. To this day.
So these guys all kind of stood in the corner over there and had their own little party.
Kind of had their own little party, yeah.
And what's this? This was again, what's this, John?
Gigantic variable capacitor inside of a tank. They put helium in it or nitrogen or whatever.
And we were there before. This one is the double-sided Tesla coil?
Yeah, dumbbell Tesla coil used in the U.S. government tests with very dramatic results that George Hathaway was able to take pictures of it.
Is this a piece that you designed, or was this out of Tesla's lab?
Well, this is my own design. There's other ones around like this, but this is my own design type.
How do you think yours differs from the ones that are already around?
Not so sparky. Sparks interfere with everything. I want to keep the sparks out of everything.
That's what Bearden talked about.
Yeah.
And what we have here is
500,000 volt Van de Graaff generator.
Is this the one that you repaired?
Yeah.
So we're going over some of these things again, but first time is kind of overwhelming.
These big variable capacitors down there.
Roller inductor too.
Yeah. Special high voltage tubes, triodes.
Now, where did those tubes come from?
Oh, I got them from the scrapyard.
Where did they originally come from?
Radio broadcast station. 1940s or 30s. I had a lot of help in those days.
Now, this is an interesting ball in the middle of 3 pieces of black pipe.
Well, let's take a look at this one here. Oh, I know it. Yeah, okay. Ah, yeah. That is a spark gap.
we talked about the spark gap that's on the top, but it's this whole unit.
This is kind of an interference system. It's black pipe, actually. Plastic pipe.
And what's the ball in the middle?
Interrupter of static.
Whoa, that's a tall one.
Yeah. And a big coil above that, too. And another coil here. Big RF choke coil. Phase shifting all the time. Suspended by non-conducting cable. Another design of mine there, too. Gigantic copper coil with insulators between. Few microhenries, but high voltage would be going through that.
The right side, it's just like a stack of insulators?
No, this is a stack of G3 mica capacitors.
Why is it hanging off the ceiling?
Well, good place to put it. Dealing with 400,000 volts.
You didn't want to ground it.
No, I didn't want it near anything.
It was basically accumulating massive amounts of energy.
Yes, sending it off at interesting frequencies. These I rescued from a scrapyard. Now they're quite valuable. So at the very bottom you put one lead, and you can actually put leads in between the two. Goes way up there.
Was there a particular unit that it would feed?
Yeah, it was 400,000 volts, vintage.
It would feed into what?
Transformer.
Now we're just kind of zipping around looking for something.
Yeah.
Oh, I think he's going to find something here. Ooh, not yet.
Not yet. He's trying though.
Oh.
Yeah, we're zooming around.
This is kind of like how you do films, John.
Oh, Don is testing out his newly bought video cam system.
Oh, and what's this? And what's that? He's kind of overwhelmed here, isn't he?
Yep. Don was into laser research. I think he's looking for some colors and stuff.
Colors in the film, huh? Okay, maybe we can get in on this. Oh, okay.
What they call a quench spark gap, cooling fins. That would spark in the middle there, and it would keep it cool, stable. That's all air cooling.
What's this next to it?
That's an RF choke. Again, vintage 1920 radio transmission station.
And these pieces here, this is a
little inductor, extra coils.
Is this more like the fine tuning when you get to this point with it?
Yeah, vintage fine tuning, let's say. More roller inductors, big giant insulator, holding up the gigantic variable spark gap. Jump to the cannon.
How long did it take you to make that, John?
Oh, I got a bill of steel, took it to a machinist to drill a hole real fast. Then I put it in the lathe and machined it and made all the carriage and everything else.
How long did it take for you to make that?
Oh, I'd say probably a week on and off.
Is there a toolbox in the middle?
Yeah. The Lewis. Vintage Lewis machine gun. World War I. Of quite the collector's item now, that is for sure.
Wow.
I was an idiot and sold it. We have in there, it should be a 50 Browning sitting in there somewhere. Various rifles, antique. We have here machine tools. Looks like a breech block. I kept all the small stuff in the vault.
What's on the shelf here?
Oh, these are all machine tools. Brass oilers. Tool parts. Live centers, dead centers. There's a nice little bull nose there. Live center.
When did you start doing machining? How old were you?
Oh, I was 5 years old when my dad took me to a machinist. When I drew out plans for a cannon. Then I was forever fascinated by this stuff. I tried making my own lathes, which I did do.
What are these things up here?
Well, these are all attachments for a turret lathe I used to have. A Warner and Swathe turret lathe. This is the front end of a 50 caliber Browning barrel. Oh my goodness, I guess I still have those.
Another cannon. Couple of them.
Yeah, a couple of cannon. That was my portable cannon under the arm, get on the bus and go to Deep Cove, rent a boat, and shoot it off in the middle of the cove.
With toilet paper, making it snow.
Yeah. The Tesla medallion, minted by a friend of mine, Thomas Lee Richardson, who was a friend of Nikola Tesla. And he gave me this medallion. Later on, I gave it to my friend in Germany, Roland.
Roland who?
Guido. Again, this is a vault I made myself to house some treasures of mine.
And what was on the side of the medallion? It was a 30 what?
That was that's a 30 caliber Browning machine gun. And now we're looking at a Lewis machine gun World War I. Some 50 caliber Browning ammo. Some vintage ends of vintage rifles. And we're moving along here.
Where did you get all this, John?
I always get stuff. I'm the best scrounger in the world. Friends, collectors.
These pistols.
Pistols and flare guns. Those are some unique flare guns. German made. World War II. English made. A Belgian revolver in the foreground. Background. Part of a shotgun.
Bayonet?
Yeah, bayonet. Back end of a Italian flare gun, World War II. Along with some other pieces, Belgian handguns. And we're moving up slowly somewhere here to a back end of another Belgian. And also a sighting mechanism for artillery.
What are these, John?
And this is both actions, parts and pieces.
So you would be doing repair on these as well?
Yeah, I'd repair them and restore them properly.
What are we seeing here?
Oh, this is getting into some pieces, some parts of machine tools. That's a Lewis machine gun.
Yeah.
Close up of it. These are extremely rare and probably worth about 100,000 now. I sold it. That's really dumb of me, but the heck. That would mount on a biplane. And I don't think it's a Red Baron. He would have the German 0815 Maxim. So, moving in here, some German guns, shotguns. That is a 50 caliber Browning barrel.
With a point on it?
I probably stuck something on the end of it. I believe it is. Various bolt action rifles. Infamous Lewis. Zooming in here at another angle at the 50 caliber Browning rounds. And let's see, my 50 Browning is probably in a box, crate. That was quite made by Colt Firearms, extremely rare. And that's a Sterling machine gun, British.
Piece of it.
Yep, sections and parts. They'll always be doing some things with them. Back end I made for it. I think we're back over to the Italian flare gun. Plastic handles and some Belgian pistols, which actually I believe I still have. Parts.
What's this right here?
That is a traverse mechanism for a 50 Browning machine gun. And a pedal mount beside it. Zooming down here, got some vintage shotgun hammer guns, of course. Mausers. Oh, cool.
Back behind on the shelf for some things.
Parts and pieces for them, too. There's a famous Johnson semi-auto. Not too many of them around anymore. Back to the Tesla medallion, knitted by Thomas Lee Richardson.
What's that symbol mean on it?
I'm not too sure. I actually forget. I think our friend is standing inside the vault filming out the Tesla lab now. Big 3-phase capacitors. Power factor capacitors.
That has a strange little form to it.
Yeah, more field shaping stuff there. And I think he's backing around filming, let's see, some vintage stuff here. We have a milling attachment for an Atlas lathe. And bullnose live centers for your lathe. Tooling. Looking closely here. More tooling, all kinds of tooling. And machinist tools, measurement tools. Some adapters for Morse taper. Measurement tools. Zooming into some rather unique tools there. A Bofors 40mm ACAC gun sight. Pintle mount for a 50 Browning on the shelf there. That is a traverse mechanism for a 50 Browning. Several of them dangling down there, as you can see. Back to the Belgian revolvers and Italian flare guns, the British flare guns and German flare guns, all sitting in there. Back to more Belgian pistols. 1880s and 1890s. Kind of just zoom it around here. Measurement tools for machining. A micrometer. Oh, that's my birth cup. I have no idea where that is. A little jerky there, so he's filming more. End of a 30 caliber Browning.
What's on the shelf?
All kinds of unique, rare vintage test pieces for machining. Pulleys and hand wheels. In the back there is a speed indicator. Zooming in on the front end of the 30 caliber Browning. And zooming in on, let's see here, leveling feet. Test stuff, some vintage meters. And hand wheel. Some cased pieces there. Now these old things, some kind of tuning stuff for mechanical Navy plotting systems. I must admit this was rather a small vault I built, but strong. Some pieces which I still have now, and yet another vault.
So what are those?
And the bullets. Artillery bullets. You'd tune them to explode.
What is it? Is it a weight? Is that a weight?
I think it's a weight. That's a 50 Browning, aircraft Browning barrel. Sitting there.
To the left of it, on the top.
Yeah, some pieces and parts of stuff. Let's see. Can't quite tell what they are at this angle. And as you can see, more pistols, flare guns, and that, I believe, is a Khyber Pass special pistol. A few of those. Made in a Khyber Pass by gun makers. Oh, there's some cool, exotic looking stuff.
There's some really old looking.
Yeah, very old looking. Speed indicator off a ship. Steady rest for a lathe. Lathe parts, accessories, dead centers, live centers, handles and levers, and jumping around. We're getting all over the place here. So we have all kinds of tooling and cannon. Oh, that's cool.
What's that to the right of that?
That was an indicator off a Navy ship. This is an index head for machining. Put it on a milling machine. Here we have a weight. Set of weight. Old vintage stuff.
Toolboxes?
Yeah, toolboxes and brass oilers down there in the corner. Two of them. More pistols. I think they're the same ones. Better lighting now. Oh yes, the famous Gasser revolver.
What's this one back here?
That was an old USSR 1880s pistol. Moving around here.
Another pan.
Another panning. And he looks like he's backing out. And backing in again. Getting more goodies on video.
So you kept all the tools in the vault here along with your gun collection.
Yeah. Small things, valuable things.
Now these are different. We didn't see these before.
These are unique, old, ancient transformers and vacuum tubes used in radio stations in the 20s. Some of them are upside down, and the ones with the 3 prongs and glass on top are little transformers. Big, monstrous vacuum tubes. They're about 14 inches high and 6 inches in diameter. Some vintage 1920s tubes. More of these transformers. Little guys. And this upside down air-cooled vacuum tube used for transmission. And getting into some more exotic vacuum tubes.
There's another angle, the roller inductor. What's behind the roller inductor?
The roller inductor behind that is a ferriometer system I built. A lot of corona suppression stuff around it. As you can tell by the window up there, it's dark at night now. Well, that's a special 3-phase power factor capacitor.
It looks like it's chipped here.
Oh yeah, it got chipped and it's moving.
Does that affect it?
No.
And this here, this is like a strange thing we hadn't seen before. What is that?
More power conditioning equipment, tunable stuff.
Things you built?
Yeah.
There you are.
There I am. There's an Atlas engine lathe. Back to the flyball governor. 2 of them, actually. With that giant pantograph generator I built. With all the different booster suppressors on it. And the giant toroid.
Static accumulator.
Static accumulator.
That's the inside of it.
Yeah, inside of it. Big piece.
Did you make that, or did you have it made? How did you find it?
Oh no, I made the centerpiece and the rest of the head turned. But I have a friend with a giant
Made out of?
Aluminium.
Aluminum.
Aluminum, yes. Moving along.
The power come out of the little ball, or would it be stay inside?
Oh, it'd be held inside.
So what's the purpose of the little ball in there?
Keep everything rounded, so there's no spraying of sparks.
Round forms are very important, aren't they?
Absolutely. They kind of hold in the energy.
Kind of like the Earth, huh?
Yeah. Oh, we're moving over back here again.
A group of guys over in the corner.
Yeah. Spiral spark gaps and spark gaps.
It fascinates me how you have all these ray guns hanging in all these different forms. I mean, this particular one has a certain function. It has all the toroids in it. It has these half globes, and then you have this one here that has 2 balls on either end of it.
Mm-hmm.
It's almost like a big garden full of different flowers that have different forms in them. Some have balls, some have spikes.
Yep, all matter of getting it done. Power condition. Control panel, again. Oh yeah, there's device 15 by 17, that was special.
What is this now?
A radar jamming system. So I used it in the hydrogen band to do all kinds of cool stuff. It was a monster unit.
So were you jamming the actual...
Just pointing it with a feed horn and shooting it into the target area.
And what would it do when it shot into the target area? What would it do to you?
Cause all kinds of unique distortion. We're zooming back in on the radio detection equipment, and what do we have here? Couldn't quite see that. Oh, a repulsion coil. I used it more for a current limiting coil. And that black thing there is the autopilot. Sitting in a round black can. And the gauges, of course. Faithfully measuring input power and what goes on, and a big giant 200 amp variac. Gifted to me by these machinery places. Back area here.
Another pan around.
Yeah. Test machines.
So these machines were generating signals as well as receiving so that you could figure out what's going on.
Oh, yeah. That's absolutely true.
The machines were generating a signal. Was that signal then sent into the high voltage?
No, it's all intermixed. Like a hologram. Wow, that cabinet there was followed you to Minnesota. But without the parts in it. And from this location, satellite electronics was not too far away. We had MacGyver people come down here, and they rented a couple of cannons from me. And we're thinking of doing an episode in this location. So here is a radar test set. Another vintage piece. Echo box. Radar unit. Feed horn. Dielectric test set for oil.
What were you testing with it?
I test transformer oil, see if it was okay or not. Feed horn from device 15 by 17. That's what it was known as. Now we're back to the RF detection VLF receivers.
Whoa, what's that?
Well, in front of you is a for testing crystallography, and beyond that is a gyroscope test set part. Yep.
Going back and forth is a gyroscope?
Yeah, for testing gyroscope. And in front of it is a scarce X-ray diffraction analysis piece.
And behind it there?
Oh, behind it? I'm trying to see what that is. Oh, okay, that's this control panel, I think. Decade boxes, vintage style, beside the X-ray diffraction analysis unit. These are handles so you can move it. A box test set inside that.
There you go.
We did it. We did it.